All right, let's dive right into the core stuff you need to know for architecting foundation model applications. If you've got an exam on the horizon, think of this as your high-speed review to really get these design concepts locked in. So here's our roadmap. We're going to walk through 6 absolutely critical decisions you'll be making. We'll start with how to pick the right model, then how to tweak its output, then how to connect it to external knowledge using RAG. After that, we'll look at the special databases that make RAG possible, talk about managing costs for customization, and finally, we'll see how to put it all on autopilot with agents. Let's go! First things first, model selection. This is the first choice you have to make, and it's so important to get it right because you're about to see not every model is built for the same task. This is the million-dollar question, right? You're going to face this in the real world, and you're definitely going to see it on the exam. And listen, the answer is never just pick the biggest, most powerful one. It's about being strategic and making a really smart choice. So how do you actually make that smart choice? Well, you use a checklist, pretty much like this one. It's all a balancing act. You've got that constant trade-off between cost and performance. Sure, a massive model like Amazon Titan gives you unbelievable power, but it comes with a bigger price tag. Then you got to ask, what am I working with? Is it text, images, audio? That's your modality. And how fast do you need an answer? That's latency. All of these factors have to fit together to solve the puzzle.
Okay, so you've picked your model. Now you need to know how to actually drive this thing. That brings us to our next topic, inference parameters. This is where you get your hands on the controls and really steer the model's output in real time.
First, just a super quick refresher, what exactly is inference? Simply put, it's the live show. The model's done all its training, and now it's out in the world applying what it learned to generate a response. So, when you ask a chatbot a question, the answer you get back, that's inference in action. And that brings us to one of the most fun parameters, temperature. Honestly, the best way to think about it is as a creativity dial. If you need straight, factual, consistent answers for, say, a technical manual, you turn that temperature way down low. But if you're trying to generate some cool marketing ideas and want some wild, out-of-the-box suggestions, you can crank that dial up and see what happens.
Next up, you've got top K and top P. Now, they both do a similar job. They control how the model picks the very next word, but they do it in slightly different ways. Think of it like this. Top K says, hey, only look at the top 10 most likely next words and just pick from that short list. Top P is a little more flexible. It says keep adding words to the list until their combined chance of happening hits, say, 90%, and then pick from that list. So for the exam, remember the key difference. Top K is a fixed number of choices. Top P is a percentage of probability.
And finally, a very simple but incredibly important rule to burn into your memory. More text in or more text out always means more cost and more processing power. When you're working with these models, size literally equals money and time. Okay, so what happens when your model knows nothing about your company's brand new top secret product? You don't have to retrain the whole thing from scratch. Instead, you can give it what's basically an external brain using a technique called Retrieval-Augmented Generation, or as everyone calls it, RAG. At its heart, RAG is all about connecting your model to real, up-to-date facts. It's an incredibly powerful way to stop models from hallucinating, just making stuff up. By forcing the model to first look up information from a source you trust, like your company's internal documents, before it answers, you make the responses so much more accurate. And the process is this really elegant two-step dance. First, as you see in step 1, the system retrieves the relevant facts from a knowledge base, maybe from a bunch of documents you have stored in an S3 bucket. Then, for step 2, it generates the answer, but it uses that specific information it just found to craft a response that's accurate and grounded in your data. So that retrieve step sounds pretty magical, right? But how on earth does it work so fast? How does the system pinpoint the exact right document out of maybe millions? Well, the answer, the engine that makes RAG hum, is the vector database. This is where things get really cool. Vector databases don't search for keywords, they search for meaning. All of your documents and the user's question get turned into these long strings of numbers called vectors. The database then just finds the documents whose numbers are mathematically closest to the question's numbers. So it's not searching for words, it's searching for concepts.
Now, for your exam, you absolutely positively need to know which AWS services can pull this off. So just remember, Amazon OpenSearch Service and Amazon Neptune are your go-to choices for handling these powerful vector embeddings.
All right, let's talk about the real world for a second. Money and effort.
There are a few different ways you can customize a model, and believe me, they come with very, very different price tags and schedules.
This chart here lays out the whole spectrum perfectly. On the far left, you've got the cheapest and fastest option, in-context learning. That's really just getting good at writing prompts. You're not changing the model at all. Take a step to the right, and you have RAG, which is a bit more involved. Then you get into fine-tuning, where you're actually updating the model's brain with new data. And way over on the far right, the most expensive and complex by a long shot is pre-training. That's building a whole new model from the ground up. And finally, let's bring this all home. How do you take all these powerful pieces and get them to perform complex, multi-step jobs all by themselves? That's where agents for Amazon Bedrock come into play.
The best way to think of an agent is as an AI project manager. It can take a big, complicated request like, find and book me the best flight and hotel for a trip to Seattle next week, and then it just does it. It breaks the problem down, calls one system to check flights, another to check hotels, and then executes the bookings, all without you having to lift a finger.
And the potential use cases here are just game changers. An agent can handle a complicated customer service ticket by checking 5 different systems to find the answer. It can manage your inventory, see you're running low on something, and automatically place a reorder. Basically, agents are how you unlock real intelligent automation.
So, to wrap this all up, if you're studying for the exam, these are the 5 key areas you have to master. Make sure you can explain how to choose a model, how to control it with those key parameters, how to give it new knowledge with RAG and vector databases, the costs of different customizations, and of course, how agents can automate the whole show.
So there you have it. You've got the Architect's Toolkit now. We've walked through all the essential building blocks for creating some truly amazing AI applications. The real question to leave you with is this. When you sit down to start your next project, which one of these powerful tools are you going to reach for first?